differentiate y squared equals x minus 1 over x plus 1. All right, the problem here is the y squared, right? Now we're used to, y equals, and then, we just take the derivative of the other side, but there's a y squared here. Now, I mean, for all intents and purposes, I guess we could take the square root, but then we end up with the plus and minus, right? So y would equal plus or minus the square root of x minus 1 over x plus 1, and then we don't want to take the derivative of that guy, right? So what can we do? Well, we can use what's known as implicit differentiation, right? We can take the derivative with respect to x of all of these, not all, right? But in this case, both sides, right? Now, if we write that out, we have dy dx, right, of y squared, and then we'll take dy dx of the right side here, okay, x minus 1 over x plus 1. But notice, okay, here we're taking the derivative with respect to x, which is fine, right? But here we're taking the derivative with respect to x. Okay, so what we're assuming here, right, what the chain rule, the chain rule says, right, is that y is a function of x, right? So we can use a chain rule along with implicit differentiation. Whenever we take the derivative of a term with respect to y, we need to multiply that by dy dx. Okay, so let's take a look. Right, what is derivative of y squared? Well, that's just 2y, right? We use the power rule. Right, so we get 2y, but because we took the derivative of this y term, we need to multiply that by dy dx. Okay? Now we just take the derivative of the right side. Well, in this case, we're going to have to use the quotient rule, right? So if we have a function like f divided by g, right, this is a quotient, right? What is the derivative of this guy? It's going to be g f prime minus f g prime all over g squared. Okay. All right, so the derivative of the numerator is just 1, so we get x plus 1 minus the numerator, which is x minus 1, times the derivative of the denominator. The derivative of x plus 1 is just 1. All of that over x plus 1 quantity squared. In this case, we notice, well, the x's cancel out. Right, that just gives us a 2 here, right? So we get 2y dy dx equals 2 over x plus 1 squared. So, well, remember what our goal is, right? We want to solve for dy dx, right? So we'll take the dy dx and we'll bring this guy, right, 2y on the bottom here. So we get 2 over 2y x plus 1 squared. And last thing to do here is just to cancel out these 2's, right? So we get our final answer, we get 1 over y x plus 1 squared. Now you notice in the final answer, we do end up with x and y terms, right? I'm not going to say it's going to happen all the time, but because we're using implicit differentiation, right, we're going to end up with y's sometimes in the final answer.